let's say x to the fifth minus 5x to the fourth minus 3x cubed plus 43x squared minus 60x. Now again, no method of factoring except that we see that there's a common factor of x through here. So I guess we could take that out. Then we get x to the fourth minus 5x cubed. And it's just dropping all of the exponents by 1 because we're taking out an x. 43x minus 60. So if we remember right, x times anything, this x out front is going to give us an x-intercept of 0. And so what we want to do with the rest of this, or we could have done it at the beginning, is graph this and look for where the other x-intercepts are. And so it looks like when you graph this, and if you do this, you're going to notice that it goes through -3 and 4. And on your regular window it looks like it's pretty steep, and so it's going right through -3 and 4. So we're going to do the same thing that we did on the last one. Now you notice that right off the bat that it doesn't cross anywhere else. So either our window's too small and it crosses left or right of where we are, or we have some imaginary roots that we can deal with. And so let's start dividing. We get 1, -5, -3, 43, and -60. And let's divide by our -3 first. Again, you could start with either or. We drop down our 1. 1 times -3 is -3. Add them together, we get -8. Multiply again, and that's a positive 24. And then 24 minus 3, or if we add them together, we get 21. 21 times -3 is -63. 43 plus -63 is a -20. Then when we multiply that, we get positive 60. Again, if you don't get a 0, we've done something wrong, or it doesn't actually cross at -3. And if you look again, you might notice that it doesn't actually cross at -3. So let's just draw a line again, ignoring our remainder over here because that's gone. These are our coefficients left. And use 4 because we noticed that it crossed at 4. So drop it down. 1 times 4 is 4. We add and we get -4. We multiply by this 4 over here, we get -16. And then we add again, we get 5. 5 times 4 is 20, and we get a remainder of 0. So again, we started with this x to the fourth up here, and we divided by x plus 3, or put the -3 here, and we got degree 3. We divided again, and we got degree 2. So this is a quadratic down here at the end, raised to the second power. So this is your constant, this is your x, and this is your x squared term. So now we have x squared minus 4x plus 5. It's a little more difficult than our last problem because the last problem didn't have an x in it, so we were able to just solve with taking the square root of both sides. But what you want to look at is, okay, can we factor this? Does anything multiply to 5? 5 and 1 multiply to 5, but they don't add to 4. So it's not factorable. You could set it equal to 0 and move the 5 over, and we could complete the square. But most of you will probably use the quadratic formula in this case. So let's, if we remember right, that's -b plus or minus the square root b squared minus 4ac all over 2a. So our a is 1, our b is -4, and our c is 5. So we get 4 plus or minus the square root of -4 squared is just going to be a 16 minus 4 times 1 times 5 all over 2 times 1. So we get 4 plus or minus square root of negative 4 times 5 is going to end up being negative 20. And so you get 16 minus the 20 gives you negative 4. So right off the bat we know we're going to get imaginary numbers there divided by 2 because we're taking the square root of a negative. So 4, and I'm going to make this 2 go underneath both of these. 4 over the 2 plus or minus the square root of negative 4 off to the side here. Square root of 4 times the square root of negative 1. So the square root of 4, that was 2. Square root of negative 1, that was I. And we divide by 2. So 4 divided by 2 is 2, and 2 divided by 2 is just I. And so there's our other two solutions, because we had 2 plus or minus I, we had our 4, and we had our negative 3. And then right at the beginning we divided by x, and so 0 was a possible x-intercept. And so if we go back now, we can just write this all out, all the solutions to x to the 5th minus 5x to the 4th minus 3x cubed plus 43x squared minus 60x. If we set that equal to 0, we just found all of the solutions for that equation. The first one we found was we factored out the x. And so the solutions are 0, and then we divided by negative 3, we divided by x plus 3, really. We plugged in a negative 3 and got 0. We plugged in 4, which was an x minus 4 factor. And then 2 plus I and 2 minus I came out of the solution. So again, degree 5, so we have 1, 2, 3, 4, 5 solutions. And in factored form you have the x, and typically we write it with what we had before we got the 2 plus I and 2 minus I. If you go back after we divided, we got x squared minus 4x plus 5, and so x squared minus 4x plus 5. I guess technically you could put this in factored form with the imaginary numbers in it, but we don't see it very frequently like that. You could do x minus a 2 plus I and x minus a 2 minus I. Alright, so there you have it. Anytime you want to find all of these x-intercepts, the very first step we took was to graph. And the whole reason we did that was so we could find some zeros. Just estimate. And then what we did was we used synthetic division to divide. And what we did was every time we divided, if we got remainder of 0, we knew that it was a root.